Mr. Anderson here for Science Lab 7, and today we're going to be talking about the Earth. But not just the Earth. We're going to be talking about earthquakes! Oh my goodness, earthquakes! You might say, well, Mr. Anderson, what's an earthquake? And here's the thing, an earthquake, these are vibrations produced when rocks break along a fault. Vibrations produced when rocks break along a fault. And so you say, well, what's a fault? Well, very simply, a fault is it's a crack in the earth, right? It's a surface along which rocks move when they pass their elastic limit and break. And when you hear the word elastic, you probably think of something that's stretchy, like a rubber band. But believe it or not, even rocks are elastic. They can bend or stretch to a point, but when that point is exceeded, that's when those rocks break, right? They pass that limit, that stretchability limit, that elastic limit, and they break. Energy gets released, that's an earthquake. So let's look at the steps there. How does an earthquake occur? Well, here we go. Step one, you have those convection currents underneath the plates, underneath the lithosphere, churning, moving that mantle material, right? Convection currents, that heating and rising, cooling and sinking of the Earth's mantle material, pushing and pulling those plates around. But again, we're talking about jagged angular plates, right? We're talking about rocks of the Earth, and as those rocks are trying to slide past each other, they get stuck. They get stuck, but those convection currents keep churning away underneath those plates. And so when they get locked in, right, the stress that's pushing them builds up. And it builds up, and it builds up until that elastic limit is exceeded. There's too much stress. The rocks break. That energy gets released, and there's an earthquake. Oh my goodness, earthquake. Right? And those earthquakes range from unnoticeable things, right? Just minor vibrations. Nobody even knows they happen. I mean, we have instruments that measure them, so we know they happen. Very, very sensitive instruments. But people, we wouldn't know they happen if we weren't able to measure that very small, very minute vibrations. So earthquakes range from the unnoticeable to devastating waves of energy. This wide range. And again, earthquakes are a result of those rocks moving under, over, and past each other at these things we call faults, these breaks in the earth. Now let's take a look at three types of faults. Okay, the first type of fault that we're going to look at is called a normal fault, which seems like kind of a strange link. It's just normally like that, I guess. But normal faults, these are faults, breaks in the rock that occur when there are tension forces. So the rocks are getting pulled apart in opposite directions, and then there's a break in those rocks. Now that break is not likely to be straight 90 degrees, straight up and down, right? More often that break in the rocks is going to be at an angle. And so it creates this ramp. And because those plates are getting pulled apart, that rock is going to slide down the ramp. Okay? And that is what we call a normal fault. It's caused by tension forces. Okay? The rock above moves down relative to the rock below. The next kind of fault we're going to look at is called a reverse fault. And it's really just the opposite of a normal fault. You take a normal fault and you reverse it. Instead of the rocks getting pulled apart, those rocks get pushed together. And then so you have that break in the rocks that's kind of like a ramp. So instead of the rocks sliding down the ramp, those rocks are going to get pushed up the ramp, right? And that's what we call a reverse fault, caused by compression forces. The rocks move upward relative to the rocks below. That's a reverse fault. Now, the third type of fault that we're going to look at is going to sound really familiar, right? It's called a strike-slip fault. And in a strike-slip fault, these are caused by shearing forces, okay? So the rocks are trying to slide past each other. So in this kind of fault, there's not a lot of vertical movement. Right? They're not moving up or they're not sliding down. These rocks are just sliding past each other. And again, that's called a strike-slip fault. So again, earthquakes, these are vibrations produced when rocks break along a fault. A fault is a crack in the earth. It's a surface along which those rocks are trying to slide when they pass their elastic limit and break. We got three kinds of faults, right? There's normal faults caused by tension forces, reverse faults caused by compression forces, and strike-slip faults caused by shearing forces. Well, I hope you learned something today. Stay curious. We'll see you next time on Science Lab 7.